Hello everyone. We are in the third section of Numpy lab tutorial. So in this section, we are going to practice how to use reshape method to change the shape of the array, and how to do indexing to access the elements, how to do slicing to slice the elements. Okay, so mainly we are going to focus in these three things. For a normal array and multi-dimensional array, we are going to perform all of these. Okay, let's get into the tutorial. First, we're going to see how to use reshape method. So as usual, you can just do it along with me, or you can just watch the video and use the PDF file, refer it to do it later. It's totally up to you. So let's start with the first concept, reshaping, how to use reshaping. So let me just make the section. Okay, so reshape function. So particularly when you work on the application wise, the data analytics or machine learning or deep learning, we have to change the dimension of the data. Okay, so to do the feature analysis, sometimes we may need to change dimension. So where we can use the reshape function. Okay. First, let's create an array. Let's first create an array by using a range function. You know, in Numpy, it is a range function. In Python, it is simply the range function. Okay. So let me first import Numpy. Okay. Now we have created a single dimensional array. Now I'm going to change the shape from single dimension to two dimension. Okay, so that we have 16 elements. So if you change it to the two dimension, then it could be like 2 rows and 8 columns. We'll see one more example where we're going to see 4 rows and 4 columns. And then we can even bring it to the 8 cross 2 cross 1 array like this, 3-dimensional array. Okay, so 8 columns, 2 rows, and the third dimension is going to be the 1. Okay, so when we pass 3 parameters, it is 2 dimension. And when you pass the -1 value, let's see, even in 2 dimension, if you pass -1 as a second value, then it will just consider the first value. Okay, you can see I'm just specifying the 4 minus 1. So it will just ignore the second parameter. Passing the negative number in reshape will pick the shape automatically from the first parameter. Okay, and there is an attribute called shape attribute that will help you to print out the shape. Okay, so for example, we have created 2 arrays. X dot shape will give you the shape of the x, which is simply 16. It's a 3-dimension. So if you look at this, the last thing we have changed it to this. Okay, and let's do the same thing for C array that we have just created, reshape. You can see the C array has 4 cross 4. That is the shape. Okay, so like that, shape method will help you to get the shape. For simple arrays like this, it is visible, but when you deal with the real world data, sometimes it will be hard to find the actual dimension, particularly when you work with multi-dimension. So in those cases, this shape method will be helpful. Okay, so next we're going to see how to do indexing. The next we're going to discuss about indexing. So when we work in real world data analytics, we need to select subset of elements from the group of elements from the group of array. We may need to select a particular row and particular column or particular element from that full array. So for that, we need to know how to do indexing and slicing. Okay, so we're going to practice indexing. Let's create an array by using a range function with some 10 values, a single dimensional array. So the same, the indexing method that will apply for the normal list in Python will be applicable to Numpy as well. So if I'm going to pick up the fifth element, the array indexing starts from 5, right? Sorry, from 0, right? 0, 1, 2, 3, 4, 5. So it will just pick the fifth element. You can see 5. Just picks that. And as we do the colon operator indexing, the same thing you can do in Numpy. Or you can do it in list or Python. The same thing you can do in Numpy. So when you say 5 to 8, it will just start it from 5, 6, 7. It will not consider the last element, but it will stop before that last element. That's how the list works, right? The same thing. Before that last element, it will just pull the elements and just pick it and display it. Okay, now we're going to see how we can change the values. Okay, normal assignment operation will work. You don't need to use any specific method to change the values. You can simply assign the values and that values will be changed automatically. For example, here I'm assigning value 12 to 5 to 8. That means 5th, 6th, 7th index values will be changed to 12. You can see that affects it. That immediately got changed. Okay. So that is how you can access the values and change the values. Now, next we are going to see how to do slicing. Okay. Slicing. Slicing is similar like the indexing, but the thing is like sometimes you need to slice the particular group of elements alone and then work on that element. If you're not sure about what is that, what does it mean? For example, here we are just indexing and accessing the element. So in slicing, what we are doing, we are creating a new variable to pick those indexed elements and then save it as a separate array. Here, array 5 to 8, we are just picking it and saving it in a separate array. So that's like this, okay? And then it will act like an array. It will act like an array. For example, we can even change the values here. It has 0, 1, 2, 3 indexes starting from 0 to 2. If you want to change the first index value to 1, 2, 3 by using the assignment operator, simply we can change the value. Okay, after we change the value, let's try to using tab add array slice. You can see we have changed that first index value from 12 to 1, 2, 3. Okay, so it is same like a normal Python method. If you use the bar slice instead of this particular indexing, if you can even use the bar slicing, that will change all the values. For example, here I have just picked that sliced array and then I just give colon and assign 64 for that colon. So in this case, it will just change all the values in the array to 64. You can see. Okay, it will change all the values. So now from 5 to 8, all the values will be assigned with the 64 new value. Okay, so now we are going to see how to copy the sliced data from an array. How to copy the sliced data from an array. Okay. Before that, let's see whether the slice, whatever we have done here, that reflects in the original array. We have just picked the array slice separately and working on that. So does it affect the original array? Let's try it. So the original array is named as ARR. So do you see whatever I have done with the sliced array, it works, it gets updated in the original array. So here I'm not calling array ARR, I manipulate that. I'm just manipulating that array slice, which is a separate array, but still it can update, it can change the original array. Okay. Okay, so if you don't want to do that, then you have to do copy method to do this. So we are creating a separate array and name it as A and do the copy. Then change these values. Okay, Now, if you do this copy method, it is not going to affect the original array. Okay, so why we need to use copy? Because when you're not using copy and slicing it as it is, then it will change the original array. If you don't want to change the original array, then you have to use the copy function to change the values. For example, and now I'm going to create a new array, and then I'm just going to index 5 to 8, and then using the copy method. Okay, and this copy method will change the values in the A array, which is a separate array, because I used copy function for this. Now I'm changing some values in the copied elements. Okay, now I'm saying it is 124. Okay, if you see, it has all the elements which 5 to 8 index, which has 124. So if I try to print, I'm going to see whether it makes this 124 is getting reflected in the original array. So you can see it didn't affect the original array. So if you want to work with the sliced data, but you don't want to manipulate the original array, then go for the copy. If you need to change the original array itself, then you can simply slice it and assign it and change it. That will get changed. That will get updated in the original array. So that's how you can work with the slicing, manipulation of original array, or making a copy of the array. So next we are going to see multi-level, multi-dimensional indexing. So when you work with multi-dimensional indexing, we have to have this understanding that in multi-dimensional indexing, elements at each index are not considered as scalars, because in one-dimensional array, each element will be considered as scalar. But when it is more than one dimension, each element will be an array itself, which is one-dimensional array. Okay, it will be the array itself. For example, you can see this is scalar, right? So you have all the value, this will be scalar. 1, 2, 3, these values are scalar. But in one-dimensional array, instead of each element, a scalar element, each element will be considered as a separate array, one-dimensional array. Okay. Sorry, I don't have the board. I'm just writing it with the mouse. Okay, so here each array element will be considered as one dimension, not as a scalar. So you have to have this understanding before we move forward with multi-dimensional array. So let's get started creating new arrays. So I'm just going to create an array with some two-dimensional array with some values. Okay, simple array, and let's see how it looks. Array two-dimensional. Okay, so it's a very simple two-dimensional array. How to access the elements in the two-dimensional array? It's very easy. We have to specify the row and column value. For example, if we want to pick the value this 3, this one, then it is in the 0 row and the second column, that is 0, 1, 2. So 0th row, 0, 1, 2, 2 column. So that will get 3. You can see. Okay. This is one way, or instead of specifying the values separately like that, even we can do it as a one-dimensional array value like this, 0, 2. So that will be taken as the 0 will be the row and 2 will be the column. Okay, now let's create a 3D array. Okay, 3D array. See, let's see how it looks. This is one row and this is one set the row values, and this one is a column value, and this one will be the third dimension. Okay, it is hard to visualize, but consider this as a cube, length, width, and height, which is the best way to. We are in 3D, right? So we can assume how it will look like in 3D. But when you go beyond that, it will be hard. But in 3D, you can see length, width, and height. So how to access the elements in 3D? For example, if you're accessing the 0 index values, then you can see it picks row and column, which is 2D itself. Like how 2D array element of 2D array is a 1D array. Like that, the element of the 3D array is going to be the 2D array. Okay, so let's do a little bit more dimensional indexing here. So you can see now it will become, you're giving two values, the first row and column in the 3D array. So that will pick this. So because it is first row, 0 and first row, and the column, 0th column. Okay, so that will pick up this 7, 8, 9. Okay, so if you pick 0, 0, if you give 0, 0, it will pick this. Okay, so that is multi. You have to imagine in terms of a cube. In that way, you can visualize the things. Now, how to access the values? I'm changing the values 1, 0 to 50. Let's see how it affects. You can see when I assign the value for this 1 cross 0, that is this index, all the values are getting updated with 50. Okay, now it looks like this 50. 50. So that's how you can manipulate the values. Next, we're going to see how to do multidimensional slicing. Okay, so we are going to perform some multidimensional slicing operations. For that, let's create a matrix. We're using two-dimensional, so two-dimensional array. Okay. Okay, so it can, since it is two-dimensional array, it can say matrix. If I work, always the matrix is 2D array. Okay, now what I'm going to do, I'm going to do some slicing on this and create it as a separate array, like how we did with the 1D array, the same thing, but we are doing slicing on 2D array. And I'm going to print that sliced values. So you can see 11, 12, 21, 22. So 0, 1, not including 2. That means excluding 2, whatever the values that will be included. That is 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, how to manipulate the values. So we can, how we did it in 1D array, same thing we can do in 2D array as well. We can change the values. We can manipulate the values. Okay, let's see how it looks like by using print. Okay, now I have changed the values. 0, 0 index is getting changed to 1000. And you can see that is getting reflected in that slice. Since we didn't copy the element, since we didn't use the copy element method, if you try to print out the matrix, the array which you have created, you can see that it changes the original value. The change is reflecting in the original array. If you use copy method in the slicing, then it will not affect the original value. Okay, let's see a few more examples with few more array. I'm just going to create another variable and name it as 2D array. And let's print that 2D array. Okay, we are going to do few more slicing operations to make you familiar with the slicing, to the multi-dimensional slicing, where I'm going to pass 2D and colon 2 and then colon 1. What does it mean? Think about that. In row 0 and 1, and in column only 0. That is the meaning, right? Let's see. So I'm going to give you a lot of examples to make you familiar, to make it familiar to you. So slice 2, sorry, maybe if it is this, then it is slice 2. Well, how about this? It will be 0 and 1, excluding the second. Okay. Okay, so by giving different examples, I'm just making you be familiar with this indexing method. Okay, let's do one more thing with the same kind of operations. Colon 2 and 1 colon, we are changing the values to 0. Okay, let's see whether it reflects in the original array. You can see we are changing the values to 0 here. Okay, 1 and the remaining values. Starting from 1 to the remaining values, we are changing it to 0. Now it affected the original array. We have to do indexing. For example, if you are going to retrieve 2 cross 2, then you can see the 2 cross 2 is nothing but this element 0, 1, 2, 0, 1, 2. So that's how we can retrieve the elements. Let's do few more operations in this example. All rows and then the last column. Okay, all rows and the 0, 1, 2. The 1 means excluding 1. So that means only the 0th column will be taken. Okay, let's try one more. This time it is 2. You can see it just picks the excluding the second, it will pick 0, 1, and all the rows, and column wise it will exclude the third column, that is second index. Okay, so let's do few more of these. What will happen with this? Yes, all columns and excluding the last row, all columns excluding the last row, the 0 and first row. Okay. All the rows exclude all the 0, 1 and 0, 1 rows, exclude 0, 1 column, and what will be the remaining thing? The remaining thing will be 9. Okay. So yeah, these indexing example will give you a good idea on how we can do that. It will give you a little bit more practice on indexing. Okay. Now we are going to do something with another package. Let's try importing the rand-in package. Okay, from Numpy has random. Inside the random package, there is a package called rand-in, and we are just importing that as RI. Okay, and then here from the RI, we are just picking that 10, 100, and 45 random index values for all three dimension, and we want to reshape it in a way that 3 rows, 5 lengthwise 3, widthwise 5, and depthwise 3. It is a little bit complicated for you to visualize, but if I do, this is how it will look like. Okay, 3-dimensional array, and then let's do a little bit more slicing on this, because in the previous example so far, I just explained how to do the 2-dimensional array indexing and slicing. We'll see few examples for 3-dimensional array as well. Okay, so if I want to do this 0 to 3 and then 0 and 2. Okay, so what it will pick? 0 and 2, 0 to 3. It will pick all the width values. So 1, 2, 3. This is the width. Okay, and then in the row and column wise, it will just pick 50, 64, and then 44. It will pick 0 and the 2. It will leave the 1. It will leave the 1. We'll do one more of this. Okay, so all the values, or we can say, yeah, we can say all values and 0 and 3. What will happen? It will just pick all the width values, and in terms of this array value 0 and 3. 50 and then 86, that will get picked. Okay, you can see 50 and 86. Okay, so it is kind of little bit complicated when it goes more dimensional, higher dimensional. It's always complicated. But when it comes to 3 dimension, you can go with the for loop, which is easy, far more easier to handle. Because, for example, you can do the same operation using for loop like this. Okay, you can see in range, it is 0, 1, 2, and then we are just passing the array, and the I value is going to be when it in 0, it will pick 0. In 0 indexing, it is going to pick all the rows and or 0, 1 row and the column value. Okay, so like that, it will be a little bit complicating when it goes to higher dimension, and using for loop is little bit, you need a conceptual understanding of that. Okay, so, but I want you to practice how to use random in library, that package. I'll give one more example on that. np.array, we have already imported it. Now I'm creating a 2D array here to make it a little bit simple. Okay, so I'm just going to run it as a here. If I give, let's do one more two-dimensional thing. So what do you think? 1, 2. It will not include the 3. It will just get 1 and 2. What is 1 and 2 in row wise, and what in column wise? What is the 2 and 4? Let's run it and see. 88. Okay, 85, and then 81 and 46. So that means 0, 1. It will just pick 2 and 3. 0, 1. In terms of row, 0 and 1. It will pick 0, 1. Sorry, 1 and 2, because excluding the 3, there is no 3. So excluding this one. And then 2 to 4 in terms of column. That means 0, 1 will be excluded. 2 and 4, excluding the 4. Before 4, it is 3. 2 to 3. Okay, so that will be retrieved. So we have seen a lot of indexing example. You have some problems given in your assignment based on this indexing. That's why I'm just giving you a lot of examples to make you familiar with the indexing. We'll do one more last indexing with this. What about this? The same matrix, 0 to 2, not same matrix here, M1. In M, I'm going to give 0 to 2. That is width-wise, it is going to take 0 and 1. Okay, 0 and 1. That is 90. This one, the last two. Okay, and then 1, 3. 1, 3. So that is 98 here, and then 43. 98, 43. Excluding this. Okay, so a lot of examples to make it more clear with the indexing. Next, we are going to see Boolean indexing. So next, we are going to practice Boolean indexing. What is Boolean indexing? Picking the index based on the Boolean value, true or false, 0 or 1. Okay, so to explain this, I'm just going to create a string array, okay, with some string values. And then I'm going to create a random array with 7 rows and 4 columns, okay, with random integer. The random n means the floating point number. Okay, I'll show you what I have. What do we have here? Okay, obviously the name will be the given. And then let's see what is there in the data, the random value. You can see random value. Okay, here we are going to do the Boolean indexing by, for example, let's say the names is the array. And here we are doing the assignment operator. This is the logical. We are checking whether a particular names, wherever we have Bob. Okay, it's not an assignment. It's a Boolean operator. Like if whether the given name, the value matches with the Bob. If it matches, then it would say true. If not, it would say false. For example, when I say Bob, it is true here, false here, true here, false, false, false. So 2 trues and the remaining values are false. And now we are going to do this, use this as an indexing for the array. So we have created a floating point array with 7 rows and 4 columns, right? We are just going to do this as an indexing. How can we do that? So we are going to pass this operation as a value to this. So this as an index to this data. So what will be the result? You can see wherever it has the true in terms of row. First one is true, so this one will be picked. The second value is false, so this will be ignored. And the third value is false, so that will be ignored. And fourth value will be ignored. And here only this value will be picked. You can see 0, 3, 2, 0. So this will be picked. Remaining 2 values false, so skip that. So this is called Boolean indexing, passing the Boolean values as an index. Now we can even also do a little bit more slicing on that. Here, in this Boolean indexing with these two values, we are just taking the from the two all rows. For example, here you can see 0, 1. Excluding that, it takes everything starting from 2. That means 2, 6, 0. It will take the second one, this one, and this one. Okay. So if it is not clear to you, I will give you one more example for this. You can see 3. So that means from this 0, 1, 2, 3, everything will be ignored. Only the last value will be picked. The third column will be picked like this. Okay, so that is called Boolean indexing. See, other than this assignment operation, let's do the negation operation. Negation, not equal to Bob. So what will be the values? So it will create an array. Wherever it was true, that will become false. And wherever it is false, that will become true. Now we have 2 false and remaining values are true because of the negation operation. Now, how can we combine this negation operation as an index value to the array? Okay, here we are saying wherever it is not equal to Bob with the tilde symbol, then what it will do, it will pick everything except this false value, the first and these two values. So either we can do this, this exclamation symbol or tilde symbol, both will work. Okay, let's do few more with this negation operation. We are creating a variable, another variable called cond, and then that's here we can pass the negation operation to this variable that we have created. This is another way to do the negation. Okay, it will do the same operation. It will give the same result. Okay, there are multiple ways that you can do the same operation, same code in multiple ways. This will mean the same thing. Pretty much, you're just assigning it to a variable. This is for negation. Let's do some logical operation. Okay, and or related operation. How can we do the logical operation? We're going to create another variable and name it as mask, and all the names that has Bob and or all the names that has Will. So we are having this logical or here. So if you try to print the mask variable, you can see you have wherever you have Bob and Will, you have 2 Bobs and 2 Wills. So in these 4 values, you will see true. In other values, you will see false. Okay. If you apply this as a mask, as a indexing for the data array, then you can see wherever it has the true, that row will be picked. Okay. So we'll do the last one with this, how to do the manipulation of the data. So here we are saying wherever the data value is less than 0, assign it with 0. So what we're saying, wherever there is negative value, we're asking it to change it to 0. Okay, so that is the meaning of the statement. So let's run it. You can see wherever we have the negative value, that value that got replaced. 0 replaces all those negative values. Okay. But these type of Boolean indexing and two-dimensional array handling will be much more efficient when we use pandas, which we are going to learn in the next chapter. Okay, but Numpy also provides the facilities, but pandas will be much more efficient in handling these kind of operations. So next we are going to do fancy indexing. So what is fancy indexing? And fancy indexing, it's like term we got from the Numpy to describe indexing using integer arrays itself. Okay, so it's like fancy indexing, unlike slicing, it always so normal indexing slicing, it always create a copy of the original array, like how we use the copy method in slicing. So that is the actual way where fancy indexing works. Okay, it will just create a copy. For example, let's create an empty array with 8 to 4. And then what we are going to do, we are going to assign the values. Empty means it will take garbage values, right? Any value. But we just created with using empty array, and then we are going to replace the values using for loop. Okay. So here, 0, 1, 2, 3, starting from 0 indexing, it will just create 0, 1, 2, 3, 4, 5, 6, 7, 8, like that. It will just create column values with the same values with different rows that we pass as an index value here. Okay, so the good thing about the fancy indexing is like you can select the subset of the row without using the for loop. You can simply pass the index value. For example, if you want to select the fourth row and then third row and then zeroth row and sixth row and then seventh row, you can simply randomly give those values as array values. You can pass it to the array indexing. You can see whatever indexing that you have passed, it will select it, which is very convenient, right? You can simply give the row indexing, then it can pick. Even you can use the normal array. Normally array 0, 1, -1 means it will start from the last, right? The same thing will work here as well. When you say -1, that will pick the last indexing value. So all the indexing rules of Python will be applicable here. Okay, so the good thing here is it will create the copy, and also you can just give any row with the row indexing, it will just pick that row. Okay, so that is called fancy indexing. Okay, so far in this section, we have discussed about normal indexing, slicing with 1D array, multi-dimensional array, 2D and 3D arrays, and Boolean indexing and fancy indexing. Okay, indexing, slicing on 1D array, 2D and array and 3D array, Boolean indexing and fancy indexing. That's what I have covered in this video tutorial. In the section 4, we are going to see some of the array creation methods, the methods which we can use from the Numpy package to create arrays. Okay, thank you. See you in the next video.